basic. It says if a function is there and I say I have a limit where x approaches p, a number, and I'll explain. It will be f of p. What does that mean? What does that mean? X approaches, this is called approaches, not equal to. There's a difference. You understand the concept of asymptotes, right? Ryan, have you heard of asymptotes?
Yeah.
What is an asymptote? Any idea? That's fine. There is no rule in this class. No question is a stupid question, no answer is a stupid answer. This is a rectangular hyperbola. F of x equals to 1 over x. Right? This is the asymptote here. What is happening here? I say as x approaches, so this is what? As y approaches, this is the if as I'm traversing to this graph, what is happening to the value of x here? What is happening to the value of x here? It's going to the infinity, right? So I say as my x approaches infinity, not equal to, what is happening to my function? What is happening to f of x?
Approaches 0.
Approaches 0. Why? Why did you say that?
Because like beyond 0, it's undefined.
It's undefined. You're talking about not defined when x is equal to 0. I'm saying, what does this mean?
X can't reach infinity. So f of x can't reach 0.
X approaches infinity, f of x approaches 0. What is the basic meaning of this? If this doesn't go into your head, see again, this is not a school, right? Where I have to just, I've got 40 kids and I have to just press the accelerator and move on, right? What on earth this means? Who can help me explain it? Very, very simple. This is f of x. And this is what I'm saying. You were there, kinda.
Is it saying the limit is 0?
Forget about the limit for a second. Right, is that making sense?
Yeah.
Do you know what does this mean? No? None? Okay. Let's take some examples here. Let's take a few numbers from 1 to going towards the infinity for x. Let's say my x could be, give me a few numbers, let's say 5, 500, 500,000. I can go even bigger, right? Let's try to find the value of f of x. What is f of x? And x equals to 5. 1 over 5, which is 0.2. Starting to get close to 0, right? What's here? 1 over 500. What would that be? Here. What's here? The value of f of x. Can someone tell me 1 over 500,000? Please give me the answer. In your calculator, quick. Someone.
0.00002.
0.000002. Whatever. Right? So what is happening as my x is going to infinity? What's happening to f of x? It's getting pushed closer and closer and closer to 0. So as x approaches infinity, f of x becomes even more closer to 0. So f dash x or f of x is approaching 0. It just means that. Nothing more than that. Does that make sense now? Right? Yeah? So, this means approaching. Right? Now, coming back to limits. You see, what we have done here is exactly what this is stated here. Let's say my f of x was this value, this function, and p was one of these values. So what actually I'm doing, I'm plugging this value into the function to find the value of y. Right, does that make sense? So as x approaches 500, which is p in this case, let's say, f of x is f of 500, which is this value. This is what limit is all about. That's it, period. So in a nutshell, whatever your, it's not equal to 500, still tell you, right? It's approaching. Because we say it's approaching 0, it's not 0, but if I have to really approximate it to whole numbers, it's 0, right? That's what it says. This is what limits are all about. You are placing your x value is approaching a value, and that value is driving the value of the function. It's just as is, just that. Now, if that's the function here, if I plug in x equals to 0, what will happen to this function?
It's undefined.
Right, what will happen to this function? 1 over 0. Not defined. So that means your function is not defined at x equals to 0. Just means that. Make sense? Now let's take an example and understand the continuity and discontinuity of a function. So let's say, shall I take this off the board? Is that okay?
Yeah.
Is limit sort of making some sense to you?
Yeah.
Yeah, we'll do a bit more deep dive, but it is important to understand what it is. Now, in its very, very simplicity, if I say, all right, limit x tends to 2, 3x squared, find the limit. So that's easy, no? Plug 2 in and find the value, which is 12. So that means as your x approaches 2, not 2, the function approaches 12 or equals to 12. A function approaches 12. Now, let's take an example here. Let's say your f of x is 2x squared minus 5x plus 2 over x minus 2. And I say my x cannot be 2 because that is where the function is not defined. Can you find the limit of x approaches to f of x? What will happen here in this case? The problem is at x equals to 2, if you plug in x equals to 2, this function is not defined, right? So I cannot blindly plug in 2 here, because the moment I blindly plug in 2 here, just like here, I'm gone for a toss, right? It's clearly stated, please don't put x equals to 2. But the limit tells me whatever is here, plug it in. So what do? The goal of finding the limit is eliminate this bit somehow from the denominator and then do the substitution. And how do I eliminate this? If I can factorize this stuff on top and try to play around with the algebra. Right? Right, Ramel?
Yeah.
So, how do I solve the quadratic? I need 2 times 2 is 4. I need the product to be 4 and sum to be minus 5. I'm just solving the basic quadratic here, okay? So, what could that be? Negative 4, negative 1. That's the pair. Now, don't tell me I need to tell you this quadratic bit. You're fine with it, right? So, let's say 2x squared minus 4x minus x plus 2 over x minus 2. So this becomes, if I take 2x common, it becomes x minus 2 minus 1, x minus 2 over x minus 2, which actually becomes 2x minus 1 times x minus 2 over x minus 2. Now, I can just knock these two off. So actually this function was nothing but, it was very simple. It was just given to trick you. The actual function was just 2x plus 1. That's it. Now it's very, very easy. And I can say, okay, now I can plug limit of x. Now there's no problem. I've just knocked off the denominator. I've freed the denominator from x's. Put 2 here, 2 times 2 plus 1, so which is 4 plus 1 equals to 5. That's the answer. Now you know what? How this function will graphically look like? If I were to draw the graph of this function. 2x plus 1, actually this is nothing but 2x plus 1, right? We just proved it. Is this going on top of your head or are you still in with me here so far?
Isn't it minus 1?
Maybe minus 1, sorry about that. Yeah, could be. So the answer is what? 4 minus 1 is 3, right?
Yeah.
This is the linear, so this must be something like this. Correct? But the problem is this bit here. Function is not defined at x equals to 2. It's given you right at the beginning. Yeah. So what we will do here is at x, let's say x is 1 here and x is 2 here. This point will be an open circle. What does open circle tells us?
Exclusive. It's like
Yeah, you cannot have this value. This is how the graph of this function is going to be. And remember, you look confused now.
no.
Make sense?
Yeah.
Yeah? This is how it's going to be. So this function is breaking at x equals to 2. This function is not defined at x equals to 2. This function is not continuous at x equals to 2. They're all the same English lines. Make sense? 100%? Right? So if you are asked to solve a limit with some condition, you cannot blindly put this value here because that will take you for a toss. So you need to find a way, and factorization is the only way to solve it. That you get yourself rid of this stuff and then plug the value of the limit that's been given to you. Make sense? Yes? Let's take an example. All right, very, very easy. I say limit x tends to 3, x minus 3, x squared minus 3x. Can you solve this, please? Now.
Okay, x minus 3 over x minus 3.
So you've got rid of the x minus 3 at the bottom. So Ayushka and Ryan, what are we doing here? We take the common factor. What is the common factor here, Ryan? X squared minus 3x. Ayushka, what is the common factor? Anyone, please?
Yeah, it's you take out x
x,
And
what's
then
inside?
x minus 3.
X minus 3 over x minus 3. Is that correct, Chris?
Yeah.
And Chris, can we knock this off?
Yeah.
And Ryan,
Mhm.
is this what it becomes? X approaches 3 as x. Because you've taken that off, only x is left.
Yeah.
And you plug 3 in, so the answer is 3. Does that make sense?
So what does this answer 3 mean? Like what is it supposed to mean?
Good question. It says that this function, as x approaches 3, this function approaches the value of 3.
Would they ever give you a question that can't be factorized at the top? Or will it always be like that?
They can't give you something which is not factorized so that you can't get rid of that.
But what if the question is something like, does it have a limit? Like, because sometimes, I remember last year some questions were like, the limit wouldn't even exist.
Let's talk about it. Alright, just to answer Romel's question. What is this telling me actually? What is this telling me? Think graphically, Romel. How do I draw the graph of this function? Basically, you factorize it to x. So the graph is y equals to x. Correct?
Yeah.
Right? What is y equals to x? That's line, right? Passing through origin. Correct?
Yeah.
At x equals to 3, this function does not exist. This function is not continuous. 1, 2, 3. This is 3. Now, what is it actually telling me? So this will be 1, 2, 3. This is 3, 3. Right?
Yeah.
It tells me that as you get closer and closer to 3, your y value will go closer and closer to 3.
Yeah.
But since you cannot be 3, your y value cannot be 3. Both of them are approaching. That is why this discontinues. As x approaches 3, the function approaches 3 as well. Function is not equal to 3. There's a big difference between equal to and approaches. Right? Make sense?
Yeah.
We'll talk about all of that, I think, next week. Don't worry, and I'll do a bit more deep dive on rectangular hyperbola, the left limit and the right limit, and what you just asked me. Right?
Would they ever like ask us to graph limits, or is it?
Yeah, they can.
So what do we graph like the?
You
first
have to
one?
graph. If the question comes in the exam, graph this. That's the answer.
So you don't graph like x squared minus 3x or anything. You just graph this simplified.
Just try this in your CAS to graph it. See what you get. I don't know. Yeah, that's a good question. No one has asked me before. Just try to graph this. See what you get. I don't know. I'm sure you'll get a straight line. I'm pretty sure. You can give it a go if you want to. Try. See what you get.
Yeah, you just put a straight line.
I tell you, yes. Did you get it?
Yeah.
Because there's no other way on earth that you can graph it, right? You have to simplify it and then graph it.
Also, when you end up with like just like a normal number like 3, does
Then-
that
Good question, yeah. Thank you for asking. Limit x tends to 4, 5. I don't have an x value here. Constant, so hence is 5. I don't have an x value to sub in. Did you get it?
So there's no limit.
Yeah, x, it is fine.
But when you graph it,
Sorry?
when you graph it, there's no limit left.
How you graph it? It's just y equals to 5. What is y equals to 5? This is 5. And this is x equal to 1, 2, 3, 4. 4. It's still 5, no?
But it's inclusive, yeah.
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 How good? Make sense?
Yeah.
Yeah. Too heavy for today?
No, it's fine.
No?